Okay, so today and tomorrow we're going to be working on some function exploration where we're going to be looking at the difference between linears and non-linear functions. Okay, so we're going to be looking at some patterns, and we definitely need our graphing calculator today. So open up the Desmos graphing calculator. That way you can be working on pulling tables and that kind of thing. Okay, so what is the difference between a linear and a nonlinear function? Well, probably the first one. First thing that we know, if it's linear, it's going to be a line. So it's going to be a line. So if it's nonlinear, somehow, some way, it's going to curve. Okay, it's going to curve. Now, the other thing that we know is that when we're looking at a linear pattern, we're looking at adding or subtracting a constant. A nonlinear could be multiply, could be divide, could be just going up, or could be going down. So we're not going to see an adding and subtracting pattern. Okay, we're not going to see an adding and subtracting pattern. So today we're going to look at all different types of functions, and we're going to see some patterns in their numbers, in their tables, and we're going to have to identify what's going on. So let's start by talking about domain and range. Okay, domain is always the x values. And range, those are the y values. Okay, those are the y values. So when I am looking at a line, a linear function, I'm using 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. I'm using all of my x's. Okay, I'm using every single x I have. So the symbol that I use is this double-legged R, which stands for all real numbers. Okay, all real numbers. I'm using everything. There are no limits because my line goes on forever. Okay, my line goes on forever. And that's the same thing with my range. The range is also going to be going on forever because my y value, I've got a value at -2, I got a value at -4, -5, -8, -10, -20, -30, -500 because my line goes on forever. Same thing with the positives. Okay, so when we're talking about domain and range with linears, it's all real numbers and all real numbers, unless we're talking about a word problem, and then of course things change. Now let's take a look at this nonlinear function. Okay, this one is actually a quadratic. Okay, this is actually called a parabola. And we're going to see a couple things here. First of all, we're going to notice that this is going down. Okay, this is going down. But I still see that I'm using all of my x's on both sides. So my domain is still all real numbers. There still aren't any limits on my x's. But there is a limit on my y. So I'm going to go ahead and draw a line at the top or the maximum of this function. Okay, it has a top. That means everything is going to go down. And if I'm going down, that means I'm talking about numbers that are less than. Remember that less than or less than or equal to, those are going to be pointing to the left. And we are going to make use of that, okay? Because we've got numbers that are less than, so this number is a -2. I've got -3 being used, -4 being used, -5, -6, -7, and this keeps going. So if they keep going, I'm going to have the real numbers less than or equal to -2 because that is where the top of my parabola is. That's the maximum. And I'm going down. Okay, I'm going down. All right, let's take a look at these guys. So this is an interesting one because this is what's called a kind of a piecewise function. It has a starting point and it has a stopping point. Okay, it has a starting point and it has a stopping point. So this one is not all real numbers the entire way. So the first x value I'm using is -4. And then I stopped at -1. I didn't go any farther than that. So I'm really looking at my real numbers staying between -4 and -2. And I leave that with my x in the middle, and I write that as a compound inequality, which you should remember from last semester. Okay? Now let's take a look at our y's. And I'm going to draw some lines here. I draw some lines here, and I notice those are open circles. So that tells me that I'm going to be making use of not equal to's, okay? Just less than's or greater than. So again, I've got my y in the center. Well, what number is the maximum? Well, the maximum is a 4. And how far down did I go? A -4. So this is really greater than a -4 and less than 4. Again, is a compound inequality. All right, what about this one? Well, this one is not a parabola. This is actually called a hyperbola because it's going to the side this time, okay? So this one has a right side. So I'm not going past the number -2 on my x's, but I am going to the left, okay? So my domain, I can actually use the real numbers again, or I can use the x, is less than or equal to, it's equal to because there's no open circle, and I'm starting at -2. So I can have x is less than or equal to -2, or the real numbers, which means every number less than or equal to -2. What about the range? Is this going to keep going on forever? Is it going to keep going this way and keep going this way? Yeah, so this one, the range is going to be all real numbers. And I just got us mixed up there. Let's back up. Okay, let's look at that again. I just did our x on our y. So my x value, no, that was right. That was right. Real numbers less than or equal to -2, or x is less than or equal to -2, and my range is real numbers. That's right. Okay, we're good. There for a minute there, I just got myself mixed up. And you can see how easy it is to get mixed up. Okay, so what we're going to start with now is some matching. Okay, so we are going to be matching a function, we're going to be matching a table and a picture. So let's start with getting our graphing calculator brought up here because we need the picture. And we're going to type in y equals 2x. And I can see it's a line, and it's a line that's going up. Okay, it's a line that is going up. So I know that so far, that's kind of what I'm looking at. And I see that there is a line that goes up right here. So that is probably my match. Now I need the table. And if you remember how to get that, I go to Edit List, which is right here at the gear. I press the gear, and then I press the table function, and it brings up my table. Now, the numbers they need are 0, 2, 4, 6. So I need to add a 4 and a 6 here so I can see what my numbers are. So I'm looking at 0, 4, 8, 12. 0, 4, 8, 12. There's near 0, -4, -8, 12. Here it is, 0, 4, 8, 12. So this is the table that matches that function. Okay? Okay, so let's answer some questions with this now. So first of all, is this linear? Yeah, it's linear. It makes a line. That's how I know it's linear. What is the pattern of the x's? Well, the x's are +2. What's the pattern of the y's? How do I go from 4 to 8, 8 to 12, 0 to 4? Those are going up by 4s. So +2 and +4. Okay, let's take a look at another set here. So I've got f of x equals 2 to the x. Okay, so I'm going to go ahead and simplify here and get rid of this guy. And let's put in, and I can put in f of x. Remember, that's the same thing as y equals. So I need to use my parenthesis. X equals 2. And I need my caret. Now remember, that is within here. That is my a to the b key. Okay, so I press my a to the b, that's going to raise it up into the power. So let's take a look at what we've got for a shape here. So that is a curve. So I see that my curve that kind of matches that is this one. And if I need to look at the table, again, I'm going to press the gear and I have this table. And again, I need to have the 4 and the 6. I'm going to type in a 4 and a 6. And let's see what we have for matches. So at -2, it's 0.25. Then it goes to 1 and 4 and 16 and 64. And I see it right here, right there. All right, let's see what kind of questions we have to answer here. Okay, so first of all, is this linear or not linear? Yeah, it's not linear. How do I know? It curves. So what is the pattern of the x? Well, the x is easy. That's +2. That's not going to change. What's going on here? How do I go from 1 to 4, 4 to 16, 16 to 64? This is not a linear pattern because it's not a line. I need to think multiply because it's getting bigger. So what times what? 1 times what gives me 4? 4 times what gives me 16? Yeah, it's 4 times 4. So my pattern is times 4. Okay, my pattern is times 4. All right, so what I want you to do is keep going with your calculator and finish up your function matching. This kind of goes along with your homework. And you're going to see some interesting patterns show up in your tables. So for example, I'm going to just pull this table up for a second and let's look at it. So if I'm going from 0, I'm going from 1, and then it says no solution, then it says -1, -0.5, and -0.33. There's no pattern here, okay? This is just decreasing. It's just getting smaller. And there are some of those where there's not really a pattern. It's just getting smaller. And those are a specific type of graph that you're going to discover, a specific type of function, and you're going to discover why there's a no solution in there as you move forward with this. So go ahead and work on your activity today. And you've got to get through about half the slides in your Desmos activity. Reach out to us if you're struggling.